Hello viewers, you're welcome to another exciting moment on our channel. Today we want to learn how to solve the quadratic equation by completing the square method. Very interesting way to solve quadratic equation. In fact, I love this method so much. So you want to stretch out because to be a long solving, you want to get your materials ready because we're going to destroy everything about completing the square method, okay? And at the end of the day, I will show you how to prove the quadratic formula. All right, so let us go right into this video right now. All right, our first question here will be this. Wow. So we want to solve this quadratic equation by completing the square. So take note of the steps I'm going to be showing you because that is how we are going to walk through all the examples we have here. So step one, you take this minus 5 to this side. So it becomes 4x squared minus 5x is equal to 5, right? Because it's negative when it comes over, it becomes positive. Step 2, if there's any coefficient of x squared, you want to divide everybody by that coefficient of x squared. Now, if you look at this guy, it's having a coefficient 4. So I will divide everybody by 4 just to get rid of that coefficient. So here becomes x squared minus 5 over 4x is equal to 5 over 4. Step 2, done. Step 3, this is the most important part of this completing the square method because this is where we actually complete the square. It says pick the coefficient of x. What's the coefficient of x here? You see minus 5 over 4. You pick that guy right here, minus 5 over 4. What do you do with it? You divide it by 2. So you divide by 2 like this because it's a fraction. So I want to write divide by 2 like this. And this is actually 2 over 1. Then the next thing you do, you square it. So a recap, pick the coefficient of x, divide it by 2 and square it. The coefficient of x is minus 5 over 4. This is write it here. Divide it by 2 and then you square it. That is the principle to complete the square. So now you get this form, you can simplify it to be minus 5 over 4 times 1 over 2. When you change division to multiplication, these guys change their position. The numerator becomes denominator and like that. So we have all square here, and that will give me minus 5 over 8 all squared. Minus 5 times 1 is minus 5. 4 times 2 is 8 and all squared. Now this guy you've got, you know what you do with him? You add him to both sides of the equation. So you have x squared minus 5 over 4x. Then that guy, this guy right here. Of course, you should know when you have minus m all squared, it's the same as m squared, right? It's the same as m squared because this negative to this even powers, the negative is going to be destroyed by this even power. You should know that, right? Let me give you a sample. If I have minus 3 all squared, the result is 9, isn't it? Because minus 3 times minus 3 is 9, right? And 9 is the same as 3 squared, isn't it? So that is what it looks like. So I'm going to add, this guy is now becoming 5 over 8 all squared. So I'm going to add him to both sides. So I have 5 over 8 here all squared is equal to 5 over 4 then plus 5 over 8 all squared, right? So this is how much we have gone so far. So next thing you want to do now is very important. So take note. Now, when you do this step, the next step you want to do, you want to write these all guys in their compact form. So you open a bracket like this, you open another one, and you close it with a square. Then this x here, you pick him and drop here. This sign here, you pick this sign and drop here. And this guy here, 5 over 8, you pick him and drop here. Just like the way you pick s without the square, that's how you pick them out. Now, I tell you, if you expand these guys, you're going to get all of this expression. That's the trick. That's the trick, okay? It works every time. So now you have 5 over 4 plus 25 over 8 times 8 is 64, right? Wow. So we are moving forward. We are moving forward right now. So now you want to simplify these guys. And how do you simplify these guys? So you say that the LCM here is 64, right? I guess so. So let me bring in my calculator. Sometimes I get stuck when I do division. So now if 64 is divided by 4, what will you get? You get 116, right? That's 16. Let me bring out my calculator. So I have 24, sorry, I have 64 divided by 4, that's 16. Then the 16 I got multiplied by 5. Of course, you should know that 16 times 5 will give me 80 here. Then I have plus 64 divided by 64 is 1. 1 times 25 is still 25, right? Of course, that's what it is. Then 80 plus 25 will give us how much? It give us, so now we have x minus 5 over 8 all squared is equal to 105 over 64, right? Now, the next thing you want to do, you take the square root of both sides, right? You take the square root of both sides to get rid of this square. So square root here, then plus or minus square root here. This square cancels out this guy. So you have x minus 5 over 8 is equal to plus or minus square root of 105. You can just leave it like that. So we have square root of 105. And square root of 64 below here is 8. So we have over 8. And now you take this guy to this side. You have x is equal to 5 over 8. You know, it's negative right here. So when it comes over here, it becomes positive. Then you have root 105 over 8. Now you can now go ahead and simplify. Let me put up a line here just for clarity. So here x1 now becomes 5 plus root 105 over 8, or x2 is the same as 5 minus root 1 over 5 over 8. So this is the value of x. You can put these guys in calculator and get the result and add to 5, get your final result. Of course, you know, everybody over 8 is the same as just taking a single denominator to be 8. So that is how we are going to solve our first problem. So let's go to the next one, question 2. Wow. Question 2, the first thing you want to do, take these guys to this side. So you have x squared minus 4x is equal to 5. The second step is to divide both sides by the coefficient of x squared. But here, the coefficient of x squared is already 1, so we don't need to divide anybody again. So we skip step 2 and go to step 3. What is step 3? Pick the coefficient of x. What's the coefficient of x here? Minus 4. Divide it by 2 and square it. You see, I'm putting the division by 2 here because I didn't have a fraction here. So it's just easy for me to divide by 2 here, and then I'll square it. That will give me minus 2 all squared, and that is the same as 2 squared, right? And then I add it to both sides. So I have x squared minus 4x here, then plus the 2 squared equal to 5 plus the 2 squared. So when you do this, these guys becomes a perfect square. So you can write them as x, you pick the x here, minus sign is here, and the 2 is here, all squared, right? Equal to 5 plus 4. 2 squared is 4, so you got 5 plus 4, which is 9. And now you have x minus 2 all squared. You want to get rid of this square, so you take the square root of both sides, plus or minus square root here. This squares cancels out. X minus 2 is equal to plus or minus 3. Square root of 9 is 3. And that will give us x is equal to 2 plus or minus 3, right? When 2 comes over here, it becomes positive. And now we have x1 is equal to 2 plus 3, or x2 is equal to 2 minus 3. And here x1 is equal to 5, x2 is equal to minus 1. Done. Next question, question 3. Oh, wow, this is interesting. This can be written as over 1. So what you do here, I want to get rid of this fraction here, which is 3y. So the LCM here is 3y. I'll multiply everybody by 3y just to get rid of this guy so that it looks very clear for me to solve it. And it looks like a quadratic equation when I get rid of this denominator. So I'll multiply everybody by 3y. So I have 3y multiplying 3y over 1, then plus 3y multiplying 1 over 3y, then plus 3y multiplying 1 over 1, then 3y multiplying 0. All right, so 3y times 3y will give me 9y squared. And of course, this 3y is going to cancel out this guy, so you have 1. And 3y times 1 will give me 3y equal to 0. Anything times 0 is 0. So you can now rearrange them perfectly. So you have 9y squared plus 3y plus 1 equal to 0. All right, so now we have the quadratic equation. So you can now begin to apply the method. Take this guy to this side. So you have 9y squared plus 3y, then equal to minus 1. Divide everybody by 9. You understand? So you have divided by 9, divided by 9, like that. Sorry. So these guys cancel out. So you have y squared plus 3 in 9 will give me 1 over 3. So I have 1 over 3 here, y, equal to minus 1 over 9. Now pick the coefficient of x, of y, I mean, which is 1 over 3, divide by 2 and square it. You see, I'm dividing by 2 this way because the coefficient of y is a fraction, okay? That is why. So this is the same as 1 over 3 times 1 over 2, because this is 2 over 1. When you change division to multiplication, these guys will change their position. Then all squared, and that will give me 1 over 6 all squared, right? So I'm going to add it to both sides here. So when I add it to both sides, I'll have, I'm going to have here to be y squared plus 1 over 3y, then plus 1 over 6 all squared is equal to minus 1 over 9 plus 1 over 6 all squared. And now when you do this, remember, this guys becomes a perfect square. So you want to write them as y plus 1 over 6 all squared equal to, here is minus 1 over 9 plus 1 over 36, right? So you should understand this principle by now. This is how it works. It works all the time. Pick this guy, pick this sign here, and pick this guy. So it works all the time. So simplifying these guys, you have, let me take these guys to this side. So you have now y plus 1 over 6 all squared is equal to, now the LCM here is 36, I mean. If 36 is divided by 9 will give me 4. 4 times minus 1 will give me minus 4, plus 36 divided by 36 is 1. 1 times 1 is 1. So I finally have minus 3 over 36, right? And I have it to be y plus 1 over 6 all squared. And now I want to get rid of this square. So I take the square root of both sides. Then remember, plus or minus square root of these guys. So I have square cancels out root. So I have y plus 1 over 6. Sorry. Y plus 1 over 6 is equal to plus or minus square root of minus 3 over square root of 36 is just 6. So I just can't simplify this guy further. I don't want to take us in a complex world. So this is just what you should leave it like for high school student. Yeah. So, but if you start doing imaginary numbers, you can go ahead and simplify it if you do imaginary numbers. Now, from here, we have y is equal to minus 1 over 6 plus or minus root minus 3 over 6. Since I'm shouting, so now we have y1 will be equal to minus 1 over 6 minus root minus 3 over 6. Or you can also write y1 as everybody over 6 minus 1 minus root 3, right? Then y2 would be taking the addition sign right now. You're taking the subtraction, so you take the addition sign. So this becomes minus 1 over 6 plus root minus 3 over 6. And that can also be written as minus 1 plus root 3 minus 3, I mean, minus 3 over 6. So viewers, this is the solution to these problems. I hope we are getting this. I hope we are getting this, right? All right, so let's go to the next question, which is question 5. All right, so this is almost like the one we just solved. I will not solve this problem. I'll just give you a hint on how to go about it. Now, this is 4r and 1. What is the LCM? The LCM is 4 times r times 1, which is 4r. So you multiply everybody by 4r. So you have 4r multiplying r over 4 plus 4r multiplying 3 over r, then plus 4r multiplying 2 over 1, which is equal to 4r multiplying 0. This 4 is going to cancel out this guy. R times r will give you r squared. This r will cancel out this guy. 4 times 3 will give you 12. Then 4r times 2 will give you 8r. Sorry, equal to 0. And now you arrange these guys in their standard form. So you have r squared plus 8r plus 12 equal to 0. Now, this is the familiar one, you know how to solve. You take this guy to this side, divide everybody by the quotient of r squared, and go ahead and simplify so you get the answer. Do you want me to do this one? All right, let's do this one. Let's just do this one. So r squared plus 8r equal to minus 12, right? Taking this guy to this side is minus 12. And now we pick the quotient of r, we divide it by 2 and you square it. So the quotient of r is 8. When you divide it by 2 and square it, you have 4 squared. Right? So you add it to everybody, you have r squared plus 8r plus 4 squared, right? Equal to minus 12 plus 4 squared. So that's good. That's good. So now these guys become a perfect square. You have to open a bracket and square it. So you have r plus 4. This is pretty easy. Just understand the steps you get to go. Now 4 squared is 16, right? And now we take these guys to this side. This is like r plus 4 all squared equal to minus 12 plus 16. That will give me positive 4. So you want to square root both sides, plus or minus, square root here. Square cancels out root. So you have r plus 4 is equal to plus or minus 2. So r is equal to minus 4 plus or minus 2. R1 will be minus 4 plus 2, or R2 will be minus 4 minus 2, and that will give me minus 6, right? And here will give me minus 2, right? So these are the values of R. You can go ahead and keep solving as many as you want. Of course, this will be an assignment for you. So I want you to solve this problem just like the way you've been taught, and put your answer in the comment section. Then now we want to learn how to prove the quadratic formula. We are going to prove the quadratic formula with the same principle, with the same steps. We'll be solving all of those examples. So the first thing, take this guy to this side. So you have ax squared plus bx is equal to minus c. Of course, this is the quadratic formula, okay? So when we prove it, we'll compare our solution. And now divide everybody by a. So divide here by a, divide here by a, like that. So you have x squared plus b over ax equal to minus c over a. Now you pick the coefficient of x, which is b over a, is a fraction. So divide by 2 like this and square. So, you know, this is 2 over 1. So you have b over a times 1 over 2. And finally, all squared, we have b over 2a all squared. So you add it to everybody here. So you have x squared plus b over ax plus b over 2a all squared is equal to minus c over a plus b over 2a all squared. Now the same principle, take these guys, this side, and this guy without their square, then all squared equal to minus c over a plus b squared is b squared, and 2a squared will be giving me 4a squared, right? Yeah, that's pretty much how it looks. So then you can go ahead and simplify all these guys. The LCM here is 4a squared, right? 4a squared. So if 4a squared is divided by this a, you'll be left with 4a. Then 4a times minus c will give us minus 4ac. Then plus 4a squared divided by 4a squared, you have 1. 1 times b squared is b squared. And I can go ahead and say this is the same as b squared minus 4ac over 4a squared, right? Of course, these guys just changing their position, right? So that is x plus b over 2a all squared. Now, the next thing, we take the square root of both sides, plus or minus the square root of these guys. Square cancels out. So you now have x, let me put down a line here for clarity. So you have x plus b over 2a is equal to plus or minus square root of b squared minus 4ac all over. Of course, you know 4a squared, the square root of 4a squared is going to be like square root of 4 is 2, square root of a squared is a. You know, a times a is a squared, so the square root of a squared will be a. Square root of 4 is 2 because 2 times 2 is 4. You understand? So that's how we got the 2a right here. And now take these guys to this side. So you have x is equal to minus b over 2a plus or minus the root of b squared minus 4ac all over 2a. Now it's almost looking like this, guys, right? So you have the same denominator, so you can convert all of them to be that denominator. So you have 2a, then minus b plus or minus the square root of b squared minus 4ac. QED, quad ed demonstrandum. So this is the end of the proof, which you call the quadratic formula. And this is the end of this video for completing the square. Hope it's interesting. Hope you find it easy. If you do, please let me know. And I want to see you in the next tutorial. Thank you for watching. Have a wonderful day and God bless you. Bye-bye.